Okay.
Go ahead.
Okay, welcome to the July 23rd, 2024 session of TAPR-HamSCI technical session. My name is Dave, KB0S, and this week I want to try something. Basically, we'll just do a roll call, and then if you have a particular topic you'd like to talk about tonight, please let us know. A lot of people bring stuff to the group to talk about and bounce ideas off. So let's try that method. So I don't have any new issues. So next on the list is Nathaniel, W2 NAF. Go ahead, Nathaniel.
Thanks, Dave. Yes, I do have one new issue. The NSF program officer for the DAISY grant emailed me today asking if we had any good figures from the Jen Gannon May 10th solar storm. So if anyone has any good figures from the personal space weather station or otherwise, please send them to me. I'm going to try to put that together for the program officer. I have some figures. I know Bill Engelke sent me some figures today. I do have the report that Gwen Griffiths sent today as well. So somehow I just have to work on getting it all into something that's digestible for the NSF to use in short order. So anyone has any comments on that later, I'd be very interested to hear them. Thank you.
Very good. Next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, all. Thank you, Dave. Minor disaster this morning. We had an hour and a half power outage when the power came back up. My original grape Raspberry Pi power supply died. So I've got to go find a new one of those. I grabbed something I used to keep a tablet charged and put it in there, but it's running awfully warm. And Nathaniel, exactly what do you want? I've got a number of graphs and things like that of the May outage or the May coronal mass ejection. Thank you, Dave.
Well,
Nathaniel, you have any comment?
Sure, you can if you just have things you think are interesting that are related to that, you can send them to me, and then I can see if I can organize them in a useful format for the NSF.
Okay, and I've sent these to the FCC on their request. Okay,
Great.
thank you.
And if you have any words about it too, so like if you wrote up in a report to the FCC, I'd be interested in seeing what you wrote to them.
Okay, will do.
Thank you.
Okay, next on the list is Jim, K4BSE. Go ahead, Jim. Any comments or any questions you want us to address?
Well, good evening, all. My brain is still kind of mush. I spent last week cruising the Blue Danube, which, by the way, is not blue; it's gray. But just got back last night late and trying to get back into the swing of things. Back to net K4BSE.
Well, you deserve a rest. Okay, next on the list is Bill Engelke. Go ahead, Bill.
Negative traffic tonight, Dave. Back to net.
Okay. Next on the list is Bob, N5BRG. Any topics?
No, I don't have any issues or topics, so back to you.
Okay. Next on the list is Dave H, W6OQ. Dave?
Hi, everyone. Nope, I'm just here to see what's happening.
Okay. Next on the list is Dave Julian, WB9YIG.
Oh, evening, folks. Nothing here to report. Just unpacking from selling at the Nashville, Tennessee Ham Fest over the weekend. So back to that.
Very good. Next on the list is David McGaw, N1HAC. Go ahead, David.
Good evening, everyone. No traffic.
Okay. Next on the list is, did I call Dave New? I don't think I called on you.
Yeah, hi. This is my second time here, so I'm just still a fly on the wall. And thanks for bringing me in on this. So that's all I have.
Okay. Next on the list is Franco K4 VZ. Go ahead.
Hey, good evening, everyone. Since we are recording, my big apologies to you, Rob, for saying the whisper didn't exist on VHF and UHF. I thought it was just an HF thing, but I realized that. Speaking of which, we are working with John Ackerman to see if we can use the VHF, UHF part of the 888 because there's also as a VHF receiver and possibly do some whisper on those frequencies. So stay tuned and we make some progress, hopefully.
Very good. Next on the list is Jay Schwartz, WB8 SBI. Go ahead.
Yeah. Well, good evening, everybody. Nothing really new in the way of amateur radio. On a personal note, this past weekend, I requalified on the pistol range for my concealed pistols license. And N8SBE, good to see you again. Since you retired, your voice on the various SAE meetings has been missed. So let me encourage you, even though you aren't collecting that from your former employer, that check every month, please continue to check in on the SAE stuff. Your voice will be heard and will be welcome there. So with that, 7-3 to all, and I'll be reading the mail. Back to net control.
Okay. Next on the list, I'm getting some shuffling of the list. Let's see. Jonathan, CCFL man. Comments or questions you want us to talk about? He's got mic muted.
Hi, Dave. I've been busy with a numerous amount of things, namely VLF related. I got full into testing the Behringer 404 HD. That's the 4-channel USB audio interface. I was testing it on the Dell Wise 5070 thin client running Linux. And I have to say, this is probably the best audio capture device that I've used for VLF. Everybody in the VLF community talks about it, talks well about it, including Paul, the author of VLF RX Tools, who uses one exclusively and is currently setting up a system, his new VLF system, or his VLF system in his new location. And it's been working beautifully. It always seems to have really good performance, no USB buffer problems. Honestly, definitely a very good choice for this VLF system as we move into the into the new project. One thing I wanted to share was the capture display. So here, this is the application called VT Scope, and it's currently capturing 4 channels, the 4 channels from the USB audio interface. I have the GPS pulse per second fed into channel 1, and I'm currently having a good success with timing. Timing is working really well. I'm using a I'm using a U-Blocks M8T in this test as well. The nice thing about this unit is that it has a signal LED, which on the pulse per second channel, it illuminates every pulse. But that only happens when the input level is set to max. So right now, the input level is just about set to max. Ideally, what it has to be on is around 80%. Also, what I'm going to do is I'm going to RC shape this pulse, and that's going to be the final timing setup for the system. I've also been doing some testing on the M8T on the Dell Wisethink client. For some strange reason, I can't get kernel PPS working. I don't know why. So kernel PPS is a part of the Linux kernel that handles the pulse per second. It's configured for the serial port, and for some strange reason, it just doesn't see it, and I don't know why. So I'm still working on that. I'm working on why that is. And then once that's done, then the timing and everything will be complete, and then I can focus on other stuff like the final designs of the interface ports. That's all I have. Back to Nanette.
Okay. Next on the list is Michael Holland, AC0G. Go ahead, Michael. Welcome back.
Thanks. Yeah, got back yesterday. I was up in Fargo at my mom's house. She's recovering slowly but steadily from a hip fracture and surgery for that. While I was there, I was able to tidy up and add some features to the monitoring, the radiometry and magnetometry sort of station I have up there. I have a 888, one of the magnetometers, one of the TAPR magnetometers. The 888 is listening to Whisper and WWV. And then I've recently added a SynthPi, a Raspberry Pi with an antenna to do some of the scintillation studies that are being organized out of the University of Texas, and installed a Dartmouth AM Doppler study kit that Dave McGaw commissioned, and we got that set up and running. So got at least a little bit of work done. And now back to mowing the lawn and trying to manage here in Missouri. Back to that.
Very good. And next on the list is Paul, WB6CXC. Go ahead, Paul.
Yeah, good evening, everybody. Thanks for letting me just snoop on you guys mainly. But one of the things I'm hoping is that I can get some or find some kindred spirits who are interested in discussing or working on time of flight, time of arrival measurements, and the modulation techniques, that may be appropriate given the recent changes in baud rate and occupied bandwidth. So if anybody's got any interest in moving forward on that, I've got a bunch of questions. I got a bunch of ideas, and I'd love to bounce them off people or possibly even learn something new. I have been known to do that once or twice. So, but that's about it. Back to Net.
Okay.
Question.
Oh, go ahead with the question.
Yeah. Paul, have you talked to Steve Serwin about this?
No.
Okay. He is our Mr. He is very active in doing TDOA, HF TDOA projects right now with HamSCI. So WA5FRF. So if you are thinking about doing TDOA, I definitely suggest you talk to him.
Okay, let me, I'm writing down because my short-term memory lasts about 5 seconds here. WA5 FRF and Steve Sherwin.
Yes.
How do I spell his last name?
CERWIN. I'll put his email in the chat.
Okay, thank you. Appreciate that.
You're welcome.
Paul, W7LUX has done some work with Steve on measuring time of flight.
Okay. So Joe. I'm interested in, what's achievable just, using plain vanilla Whisper. And then if we want to or need to increase the measurement resolution, what type of additional modulation, a spreading or, a chip rate kind of thing, just modulating in the existing format, or just coming up with something brand new, which would be kind of nice, again, with an eye towards taking advantage of our occupied bandwidth rules. So, Joe, is there a way I can get in touch with you and Nathaniel? Okay, you're giving me Steve's contact. So
Yeah, I put Steve's contact in the chat.
yeah, I gotta find the chat here. Okay, here we go.
I will add mine. Mine is just W7LUX at ARRL.net.
Okay, great. I'll send you guys both email, and then just let's see what kind of stuff we can share. I would appreciate bouncing some things off guys who have already been thinking about this issue.
Steve is sort of the expert on this.
Okay.
Yeah, and Paul, I'd like to be in the loop too.
Okay.
David, M1HAC.
Okay. No, I'll happy to coordinate, either just email chats, or we could do a video or whatever. I'm, for the moment anyway, this is something that I just really want to kind of get a handle on.
Where are you located, Paul?
I'm in Friday Harbor, Washington State, but I'm also slightly less than half the time I'm in Occidental, California. So I bounce up and down between the two areas, really.
Where is your equipment?
Both places. I got I got ham gear in both spots, but most of my test equipment and development gear, small scale manufacturing kind of stuff, is up here in Friday Harbor, Washington. That's where I do assembly of the stuff that I build.
Okay. Let's go ahead and finish the list. Next on the list is Scott Newell. He usually doesn't have a mic. Okay. And then we have Tom McDermott, N5EG.
Oh, good evening, Dave, and everyone in the group. Not much to report. Been writing Verilog all week and have yet to simulate it. So that's it. Back to the group.
You don't have any reports on progress?
Progress. No, I've been writing code, if not simulated said code.
Okay. Okay, very good.
And it probably won't.
But we're all very interested in what you're up to, so.
Okay. Well, I'm trying, I coded up the overhead streams for the FPGA that signal multi-frame, AB, which lanes on what edge of the clock, and the overhead overflow counts for the 4 A to Ds, and it packages those all up and spits them out in place of the LSVs of the samples.
Okay.
So the host knows what to do with all the data.
Yes. Very good. Next on the list is Tony, KB8 MVP. Go ahead, Tony.
Hello, group. I was fortunate enough last week to attend the IEEE NACON conference. That's the National Aerospace and Electronics Conference right here in Dayton near Wright-Patterson Air Force Base. Some very interesting papers presented on high temperature electronics, microwave devices, really pushing the limits of semiconductor physics, the commensurate artificial intelligence and machine learning, of course. And on the RF side, there were a lot of 5G and 6G discussions. Yeah, 6G is being defined as we speak. So it was a very productive week, a lot of very interesting papers. That's all I have.
Okay, sounds like an interesting meeting. We also have Robinette, AI6 VN. Go ahead, Rob.
Hi. Okay. I think the biggest activity I think was that we got WW0 WWV back up on the air last week. I mean, that's really Dave Schwartz's activity, but it's Paul's Whispersond 8 and that he installed, and an antenna that I donated. But really, it's Dave went out there and put up the antenna and did the installation, and it's working marvelously. And Gwen has produced some preliminary comparisons that show just perfect tracking between Doppler shift from the WWV carrier as displayed by the grape charts and the data that we log, our receive sites log from the Whisper Demons extended spots, which also log the frequencies and such. So I think that's a major thing. I think we're putting together there's going to be a press release put on up on the HamSCI site, and maybe sent out maybe to ARRL and others who might find it interesting. And when that happens, I think I'll go over to the whispernet.org and make sure they are all aware that there's now a WWV Whisper beacon on air. So hopefully that will promote all of our activities by making our enterprise more widely known among the at least the Whisper community, which isn't, there's thousands of them. So that'd be a good group to know more about us. Anyway, that's it. I'm working on Whisper Daemon 3.0, just about done. And when that happens, we'll have spectrum displays as well as, of course, support for the 888. And I think we're going to have VHF and UHF support if Franco's driver works as advertised. That's what I'm up to. Back to Ned.
Very good. Looking forward to it. Well, I think I've called everybody. Is anybody not been called? Oh,
You didn't call me.
oh, didn't call
Not
Dave.
that I have anything to say, but
Okay.
I really don't.
Well, you're busy with a few other people, with Franco and such on projects.
This, that, and the other.
Okay. So, anybody else? Then we're open for general discussion.
I am curious regarding time of flight that Paul was asking about, whether or what thoughts people have about the use of CODAR. Steve Kepler, I know, has worked on that in the past, and Phil Karn had mentioned it not too long ago. And in fact, at Dayton, that there's an existing waveform there that has some known chirp characteristics that's used for coastal radar in HF that are receivable, of course, by a 888 or any other, but they're quite wide bandwidth, and so a 888 is pretty nicely capable of picking that up.
Is that spelled KODAR or CODAR? Do you know?
The latter, CODAR.
Okay. Yeah, I mean,
there's commercial products that are stationed along coastlines all over the world sending out an HF radar signal, of course, for purposes of local purposes of defining wave patterns offshore, but they're audible all over the place. And with the known characteristic chirp like that, time of flight, I think, is from a radar perspective, is one of the things that it's designed to do out of the box. We don't have to reinvent a new waveform potentially.
Yeah, I mean, if we're going to transmit in ham bands, we're stuck with occupied bandwidth. But I mean, I'm familiar with chirp radar and the UHF region, and you need to know. I mean, the chirp gives you great ranging for the reflected signal, because you can compare your transmitted signal, modulate that or mix that with the received signal, and the difference in hertz is basically the distance the time of flight. But you would need to know the time of transmission in order to be able to decode time of flight out of that. I think any of these, you're going to need to know when the transmission actually started. But I'll look up CODAR.
Yeah.
And who did you?
I think so. One comment on the time of transmission. I know with some of these projects, like the GNU Chirp Sounder project that UHOT does, where he's listening to signals of opportunity of chirp ionosons, they make the assumption that all of the transmissions start on the top of like a GPS minute. So they use that as their assumption, and they seem to get good results from that.
Yeah, and that's perfectly good, as long as you know how accurate the transmitter timing actually is, and there's no reason why it shouldn't be more accurate than the thing you're measuring.
Yeah.
I'm going to send out email to the three of you who had expressed interest, and just collect more information here. I'd really appreciate it.
Tom McDermott had a comment.
Delay in the various transmitters due to the signal processing part of the radio.
Yeah, I mean, that obviously needs to be factored in. Hopefully you know what that is, and you can, sort of correct for that when you send it.
I can actually correct for that.
Yeah, I mean, as long as it's, kind of deterministic, as long as you don't have some weird networking interrupt thing going on, but as long as you know what's happening and when it's happening, that shouldn't be too hard to do. And the other question I've got about the whole thing is what level of accuracy would we like to get, or would we expect to be able to get? I wouldn't want to start designing for something in the nanosecond range when we know that the thing we're trying to measure is more in the tens of microsecond or hundreds of microsecond range.
Hundreds of microseconds.
Yeah.
The ionosphere is pretty interesting. I've spent a long time watching the ticks, the 1 second, 1 per second ticks from WWV and WWVH, and they do vary around quite a bit. I have a question for the group. Somewhere I vaguely remember hearing that there was a program available that would let you get a good estimate of the height of the ionosphere by looking at a time of flight value. Does anyone know what that program might be?
Gwen did such an analysis from the Doppler shifts in the October eclipse, and I don't know the technique he used, but he is the one I would talk to about this. He looked at the difference between different bands, as I recall. We were transmitting simultaneously on multiple bands, And
Okay.
I think he was looking at the Doppler shift on each of well, there were three bands, 80, 40, and 30, that were useful during the eclipse. And I think he looked at the Doppler shift between the three of them, then factored that, the Doppler shift was a function of frequency and then used that information to determine the change in the depth of the ionosphere. But I don't recall any more details of the algorithm. Gwen is the person to talk to about this. He's
Okay, super.
I would like to mention that Phil Karn just joined us.
Hey guys, yeah, I had my last chemo infusion today, and it kind of weirds me out. So I went home, fell asleep, and forgot about this thing. But then I woke up and remembered.
Oh, glad to see you're here. Yeah, Phil, we were talking about time of flight, or I'd sort of broached the subject, the modulation and measurements and all of that. I'm hoping to get an education on the subject and maybe help see this into something that we can actually implement. So you're the one everybody points to when the subject comes up. Wondering if you've got anything that you could in a position to share as far as your thoughts on, what the goals and techniques that would be appropriate are.
Okay, first thing I can say is that from a theory standpoint, any kind of delay measurement is going to require a signal that has bandwidth. So far you've been using these ultra narrow carriers, which are great for measuring Doppler, but terrible for measuring delay. And delay is, a range actually, as they call it, radar. But it's a different story when you're measuring actual time delay. So we now have a 2.8 kilohertz bandwidth limit for data in HF, and I guess we can make use of that. The accuracy with which we can measure distance is roughly proportional to the inverse of that bandwidth. It's not quite as bad as 1/2.8 kilohertz, times the speed of light. It's because you can measure to a better resolution in one complete, cycle of whatever modulation you're using. You can go to some fraction of that. But anyway, it's a rough rule of thumb. One question I have for you guys is how many stations do you expect to have? How many? I assume they're going to be operating full time, because if we're using that much bandwidth, we'll probably have to find a way to make those signals coexist. And that's a little more difficult when they're that wide. I mean, with Whisper, they can all coexist by sitting next to each other in a, relatively small frequency channel. But when you have to use more, you have to take you have to find some way for them to coexist. One way for them to coexist is from the transmit round robin. Would that be acceptable if each station is only, if you're having each station or small number of stations transmitting one at a time, and so you're not getting continuous measurements of distance from each station all the time? Would that be acceptable? On some channels, like the space channel, when you're tracking a spacecraft, you use a combination range and range rate. And the range rate or a Doppler can keep you going between range measurements. For example, in the Apollo spacecraft, they could measure both. They could measure range rate all the time with a coherent Doppler scheme using the carrier, which was on all the time, and a coherent transponder. And then if they ever lost track of the actual distance, they could turn on a ranging signal, get the absolute distance, and then turn it off and just count cycles of the carrier from there. The problem with on HF, of course, is we have a lot of fading, and I've been playing around with this, and of course, anytime you have any kind of significant fading, you're going to slip cycles and then be uncertain about exactly which your distance is. So that scheme will probably not work for us except when the conditions are really good. So it probably means either using a lot of bandwidth or taking turns. And I guess my question to you guys is that acceptable? I'm going to need some hardware support, of course. When transmitting, I need to be able to send some arbitrary signal. It I mean, you can start by dedicating a single sideband transmitter. Phase response to that transmitter is probably going to be uncontrolled, so I'll have to either compensate for it or use some fraction of his bandwidth that has a flat group delay response. Or I could have somebody, make a transmitter that has well-defined controlled phase and group delay characteristics. So, I mean, it really all depends on what kind of hardware you guys are ready to build and what kind of results you really have to have.
And the hardware, is going to depend on the type of modulation that we would like to use.
Well, yeah, although the hardware should really just be general purpose. I mean, it's some kind of IQ modulator that can give me, well, I'd say it's flat out to 2.8 kilohertz. I mean, it can go wider than that. That's the easiest way to make it flat to 2.8 kilohertz. But it really ought to be general purpose, so I can run any waveform through it, including carrier.
Just let me say perhaps. I mean, general purpose is great. Depends on our goals and our budget and how many and again the type of signal. Can we get away with something? Can we create a useful system where let's just say it's just plain FSK or PSK? Something simple to generate. Is that? Or do we need
plain FSK
quadrature modulation on the thing?
Okay, plain FSK is certainly easy to generate with constant envelope signal, but then you have to worry about what side lobes are going to look like. It's always easier to control side lobes if the system can be linear. Now, I assume low powers will be sufficient. I mean, you guys have been working with very low powers in Whisper, and as a result, not really bothering each other. Ranging signals really ought not to be any worse than that. I mean, you could probably use similar amounts of power because there isn't a whole lot of information you're, quote unquote, sending with this signal. The information you're sending is added by the channel. You're sending a signal with no information. The channel is adding the information that you want to pick up. If you look at it that way from information theory. So the power level doesn't have to be high, which means you don't really need to have an efficient transmitter. It can be low power, and therefore it can be relatively easy to make it linear.
But it needs to be limited. But it needs to be linear, right?
Unless you go with the constant amplitude signal.
Right. My point is that it's much harder to control the spectrum of constant. It can be done. It really constrains your design choices. If I want to make a limited signal.
When we say occupied bandwidth, I mean, that's like the 99%, 20 dB down sort of thing, right?
Yeah. And at lower powers, you probably really won't need, good side lobe suppression to avoid bothering.
I mean, basic FSK at, 1 kilohertz symbol rate gets you, under 2.8 kilohertz occupied bandwidth. I mean, it'll be a nasty signal that, if somebody didn't want you to interfere with them, but I don't think I think within the occupied bandwidth, we can do some pretty fast, chirp rate or whatever you want to do on a constant amplitude signal. Hey guys, I didn't mean to drag us into the weeds here on that, unless you want to continue this degree of discussion, but it's something I've been thinking about for over a year now. So obviously I'm interested, but we could take this offline if you had, Nathaniel, if you wanted your meeting back.
Oh no, keep going. You're
okay.
I think we'll let Dave is really in charge of this meeting.
Well,
so
this is a development meeting where people have ideas and we're trying to develop them. And we originally started with one radio, and now we're basically moved to K9Q radio. And Rob has added all kinds of modulation modes that he wants for work. And so it's a dynamically morphing type of group and or type of studies, and we're basically exploring what can we do with the kinds of hardware and software being built.
Okay, so the way I can
time of
summarize
flight is logical follow on to the Doppler.
Yeah, I can say that if you want to get maximum range resolution with the minimum bandwidth, you want to get as much as you can out of 2.8 kilohertz. I think you're pretty much going to have some kind of transmitter that can generate an arbitrary envelope and phase. Sure, you can do with less, but if you really want to get the most out of 2.8 kilohertz, then that's what you need. And if you're talking about power levels of a watt or less, I mean, how much power does your beacon put out, Paul?
It puts out roughly 1 watt per channel.
Yeah. And I mean, that's not hard, is it?
No, that's trivial, but that is a constant amplitude driver, and there's nothing. I could. It's going to take a different type of transmitter if we go something that's non-constant amplitude, and that's fine. That's fine.
Well, there are two things. First, you don't need an absolutely linear transmitter. You can pre-distort it.
That's right.
Second, you can get improved resolution by using coded waveforms.
Sure. But
So,
just talking from a theoretical point of view.
the bandwidth isn't an absolute limitation.
Well, it is a limit. We have to obey the rules, right?
No, I'm not saying that. I'm saying in terms of distance accuracy. If you use a extended coded waveform, you can improve your resolution.
Describe coded waveform. I mean, we're not talking about
these
about
will
coding.
be
We're talking about a
waveforms.
waveform shape.
I mean, the waveform will be coded. I mean, it kind of has to be if you're going to measure distance.
Right, but they're like pseudo-random type codes that allow you to recognize what part of the waveform you're in over an extended period of time.
Yeah, and there are lots of them.
And improve your resolution. I
Yeah,
mean,
books on
UHA
radar.
was using that for the low power ionosondes.
Yeah, books and radar have a lot of these things. I've been studying them.
So in this the eclipse from last October, I was one of the stations that participated with Steve Serwin in the TDOA on HF. And so we had these coded transmissions, if you will, that consisted of various clicks and chirps, and and it all was contained within a 2.8 kilohertz bandpass, just sent over a regular sideband radio. So I guess the question is that a good place to start from, or is that just so completely off base that it's not useful for this?
No, I mean, your signals, you're on the right track with your signals. The question is, how close did you get to the theoretical limits, given that you have to stick to that kind of bandwidth? I mean, what kind of range resolutions did you get?
Yeah, I haven't seen any papers written based on that experiment yet, so I'm not certain what really exactly how far it's going.
Yeah, I mean, you can often do better. You can often do better than simple conservative theory would say. I mean, look at GPS. GPS actually works a lot better than it was supposed to.
Yeah.
I mean, that's why the government introduced, the dithering of the signal until about the year 2000. But there are still theoretical limits.
And to point out, GPS is an example of a coded waveform.
Sure.
Sure.
And it's a CDMA waveform. It takes advantage of the fact that the signal levels from the satellites are all roughly the same for everybody because they're all roughly the same distances. We have the problem that there are going to be some near transmitters and some far transmitters, and that's what I mean about maybe having to time division multiplex the channel among our transmitters. I mean, I can use spread spectrum. I can get a certain amount of process gain, but I'm not sure it's going to be enough. Because each station is going to see some signals that are much, much louder than others.
You could, to some extent, you can deconvolute them out, can't you? You find them.
Yeah, I was going to say you can do that to a certain amount. That's probably the biggest uncertainty. That's the thing that's going to require the most experimental work, is to see how much that you can do. But I would assume that we're going to have to do some kind of, I mean, how many transmitters are you going to have? What is that number?
There's only 3,300 whisper beacons out there, so you know it won't be more than that.
Well,
So I know one of the things that you mentioned, Phil, was the idea that we would have to know exactly when the transmission started. And yet that didn't seem to be a concern for us when we were doing this experiment, because apparently the coded signal essentially sets its own time base by the coding that's in the signal. I'm not
well,
exactly
sure. Yeah, that's one way you do what I said you had to do, which is to know when the signal started.
Yeah.
It has to be complicated, and the signal has to be complicated enough that there's no ambiguity over the uncertainty of the time of arrival. So there's only one answer, to the question of, where did this thing begin? What time did it begin?
I do think we've in last week kind of solved the receive part. I mean, we have a design, right, with for a receiver that I think would allow the receiver to know what time the received signal arrived, right? I mean, the idea of putting in those two full-scale samples at the top of each minute, or I guess it was the thought, something like that, that would allow your software to establish when when the samples where the start of a second.
Do it every second with a PPS. I mean, I see that part of it is essentially solved, at least in principle.
Yeah, I think we solved that. I mean, it has to that has to be. We need a receiver that incorporates that capability.
Right.
Oh, I mean, that requires a new receiver design. I mean, there are ways to do this with the existing receiver where you basically generate a local reference signal of the same format that all these other transmitters are generating, and you inject that into the receiver input, and it gets decoded along with everything else. But that becomes your reference, and that way you can do it with the existing AAAs probably.
Yeah, that'll work too.
But again, how complicated is this transmitter? Is it, if the I'm not, I don't think that we necessarily need to find, the best signal and noise or the best possible signal, theoretical possible signal. I think there's going to be some trade-off between implementation difficulty and performance, and what performance is good enough, and it would be nice if whatever we came up with in terms of modulation and coding and protocol were extensible. You could have a baseline, that would maybe that would be the time of flight stuff or start, and then you could add on different M-area types modulation. You could expand the constellation for other purposes, but it would be
I have to admit, I have an
way.
ulterior motive here. I've been wanting a general purpose IQ transmitter for
That's what I was afraid of. That's what I thought you're going to
Well,
tell me.
It does not have to be high power. It does not have to be a 1 watt. It would be plenty for the kinds of things I'm talking about.
I'd be all for that. But I also am hoping that we can come up with a simple system for time of flight.
All right. How about we come up with both?
I'm all for that too.
I'll see if I can come up with 2 waveforms. The ideal waveform and then the constant amplitude one.
Yeah, the stupid WBCXC waveform would be
okay. But now, Paul, how rapidly can you shift frequencies using the 5351? How rapidly can it?
I could do kilohertz rate. I could do 2 kilohertz rate. That's FSK. I could probably also do PSK at that rate. But at that rate, I've got no frequency transition shaping. It's not going to be GFSK. It's just going to be plain FSK.
A good point, because I think if you need to control spectrum on a constant amplitude signal, you're going to have to use probably some form of MSK.
Yeah, and so in that case, depending on how many steps you want, let's say I can do a 2 kilohertz frequency change rate. So if our symbol rate is 1/16 of that, then I can do 16 frequency steps. That gives you a awfully nice GFSK waveform. Frequent spectrum. The sidebands are significantly down if you do that. Even 16 steps from one symbol to the next. So anyway, that's
you're saying this would be MSK but 16 times slower? MSK is where minimum shift keying is where the shift is exactly 1/2 the symbol rate, I think. Yeah.
Yeah, I mean, we're not stuck. It doesn't have to be MSK. I assumed it would be, but it doesn't have to be. I'm saying I can generate FSK with the individual frequency steps, changing at probably as fast as a 2 kilohertz rate. And then those frequency steps are what I would use to generate, so let's say, Gaussian frequency Gaussian shaping of the frequency shift.
Okay, it'll be Gaussian. Okay, MSK.
Or what any shaping function that you want.
My point is, you have the timing of these shifts would have to be precise.
Yeah, and I'm pretty sure I can do that. I mean, I know I can do that given the right hardware. But
see,
even
if you
with
just
this,
had an IQ transmitter, then you can do this in software very precisely. You wouldn't have to worry about that part.
Yeah, and I've been thinking about the IQ part. I mean, it might be time for me to. I've done FPGA work in the past, and it might be time for me to do that again. But anyway, it's.
I mean, yeah, with a fast enough DDA converter, you can just generate the RF waveform directly, and then you just amplify it.
Yeah, or an intermediate.
Do the IQ mixing in software, right? And you end up with a. I mean, look. I mean, how much does it cost? I mean, I haven't priced DDA converters running at RF clock rates yet. Anybody know?
No, I haven't looked lately, but they're not horrible. I mean, the 888's got that's an A to D. D to A's are got to be cheaper than that.
That's what I meant. Yeah. So anybody know what a D to A that can clock at 60 some megahertz costs?
It's not much. I don't know. I'd look it up, but
looking at Tom N5EG, he might know.
Or Francisco.
Yeah, or Dave McGaw. My hardware guys should know. Or Bob N5BRG.
Yes.
I haven't bought one in a while. I don't know what the pricing is now.
Yeah, they got to be cheaper than 8 of these. They got to be.
And
considerably.
And these wouldn't be would these need to be 16-bit A to Ds or
probably not, although I don't think
be that precise, no.
Yeah.
But I don't think that the resolution is going to be a particular cost issue. The type of probably 8-bit would be good enough.
Red Pataya has them in it.
As the what?
Has 8 DAs in it.
Yeah.
They run at that rate.
Okay.
They think they're 14-bit, but
yeah, and if the power level is low enough, you don't need really precise steps in order to push that stuff all the way down below the noise of anybody except maybe somebody next door.
Yeah, no, I've done RF synthesis with D to A's. I've built up inside gate array feeding a couple external resistors, so it's like 6 or 8 levels, and the spurs can be way down if you pick your frequencies right.
You say you build the D to A's out of an FPGA?
Well, these days, I mean, you could, but you'd probably be better just to buy one.
Oh, I agree. Yeah, that's why I was asking.
Yeah, no, but I'm saying just all I'm pointing out is that you don't necessarily need a high resolution D to A to get a perfectly acceptable signal, especially if you can control where the spurs end up, you can get rid of them.
I mean, we used to build D to A's out of just, parallel output gates and a bunch of resistors and a resistor ladder. Remember? Yeah.
No, that's one of my first chips did that as a It's a synthesizer for an internal clock that we couldn't get any other way.
Phil, the one that we're using for Phil Harman's is 9744. It's $20.
$20 in samples. How fast?
I sent you the link there from Octopar, so there are several places that have it. It's in the chat here.
Got it. Okay.
Yeah, DigiKey or Mauser had $20 for 14-bit, 125 megasample D to A.
Okay, so we're in the range of trivial here.
Might even be overkill, but hey, okay, at least we have an idea. Of course, we need one for every band we're transmitting on if we're transmitting on more than one.
Well, it depends on what kind of linear amplifier you want. You could combine them. Oh, then you probably do need resolution.
So I'm looking at analog devices, 14-bit, 210 megasamples per second. That's kind of overkill.
Yeah, I'm looking at a 10-bit 170 megasample from analog devices. Okay, DigiKey. Again, the price is. Oh, come on.
You also want these things to be around in the market for a while.
Yeah, yeah. Oh, here we go. 1,226. Okay, you don't buy it from DigiKey. But anyway, so yeah, there are ways to do, I'm sure there are ways to do it with the D to A. And then you need if you can if you can correct for linearity on the amplifier, that could be pretty easy. Yeah, especially if you're only doing one frequency, one channel at a time.
Yeah. It wouldn't be hard to pre-distort the IQ signal to do that if it's going just through a well-characterized amplifier.
Yeah. And I mean, there are the techniques where the receiver, it's got a built-in transmitter, it's got a built-in receiver, and it feeds that back, and sort of a feedback feed forward thing. But again, that's starting to sound pretty complicated to me.
No, you could just use your own station. I mean, most of these stations are going to have receivers too, at least when you're setting them up. So you use your own RS-888 and receiver chain in order to do that.
Yeah, my recollection, Warren, when he did pre-distortion back in HFSDR, he found thermal memory effects in the power FETs. And so linearization was a lot more than just correcting for bending or kinks in the slope. You had to actually worry about in the millisecond range, the thermal changes in the FET. But that was with like 100-watt FET. Lower power FETs don't quite have.
Was this a second order effect, Tom, or is this something that showed up right away?
I think it showed up pretty significantly. He was trying to get the third order products down like below 40 dB down from the carrier, and I think he was struggling with the memory effects.
Okay, I'm not an amplifier guy, so I don't actually know what numbers are reasonable, what numbers are hard.
I know in the high power microwave, that's a big problem, is trying to compensate for that.
Yeah.
I want to build something that I can hold in my hand. That's
well, maybe a 1-watt part doesn't really have these issues.
Well, Paul, you've already built 1-watt transmitters. I mean, how warm?
Yeah. No, they're definitely constant amplitude. They're just basically line drivers that are they're
well,
on.
they're still probably not anywhere near 100% efficient. I mean, how
no, not at all.
How warm do they get?
Yeah.
No, they get warm. I put heat sinks on them. They're about a little bit better than 50% efficient, but not by much.
Yeah.
It may also be that constant amplitude signals are a lot easier to linearize because the power dissipation is not changing, you know, at the kilohertz rate.
If we got
Yeah.
constant amplitude signal, we really don't need to linearize it. That's the beauty of
Look,
it.
I mean, it is going to be constant over all but very short periods of time, right? I mean, modulations at 2.8 kilohertz. That's, you know, what, a couple hundred microseconds, right? You know, and over
Yeah, I mean,
a reasonable amount of time, it's going to be flat.
if we can, yeah, I mean, if we can come up with just a couple, like, you know, a 3-level signal or something, I don't know, and quadrature, you know, maybe a 4-point constellation or something. You know,
Yeah, well,
that could get pretty easy.
yeah, the more degrees of freedom, the merrier. I don't have to have infinite, but you know, it's nice to have something.
But you know,
I guess it's
we
probably time
need
to start making some waveforms and experimenting, I guess.
I guess so, and I think it's also time to figure out goals, you know, basically requirements and schedule, you know, the desired schedule for this too, because this is the sort of thing where I definitely would not want to see the perfect being the enemy of the good enough.
Sure.
But I, you know, I'm pretty naive when it comes to this higher level stuff. So I'll be happy to sit back and watch the smart guys figure it out.
I keep wondering if you guys are have looked at actually using Codar signals and other existing things that are already on the bands to do a lot of what you want to do.
Yeah, Michael had mentioned that. Is he still here? Anyway, mentioned that you guys had talked about Codar. I'm going to look at that. That's not going to be a ham legal signal from what I understand, though. So, but maybe
No, I
if
mean,
the
use the
transmitters are
existing
already out
Codar
there,
use the
just
existing Codar transmitters.
yeah, like we're using WWV now. So,
Right. Right.
If we understand their characteristics, their time of transmission, you know, what I was kind of hoping is that the payload, whatever this protocol is, would include time of transmission as one of the fields in there. Although if, you know, all transmissions are going to start on a 1 second or 1 minute boundary or whatever it is, then I guess maybe we don't need to know anything more than that. But it seems like for a general purpose thing, it would be nice to know when the time of transmission started.
I'm pretty sure the Codar signals are already synchronized to GPS. They do that so they make them orthogonal with multiple transmitters on the same channel, as far as I know.
And
the ones
again,
I see, they seem to be.
Yeah, and this question of time slotting, you know, everyone getting a time slot or something. You know, that sounds fine as long as we understand what it is we're trying to measure, and you know, will those gaps cause us to miss stuff that we didn't know was there? I mean, another approach, Phil, is, you know, sort of a quasi-random transmit schedule. At least there won't be constant stomping on it on other people's feet, just occasional. But at least that way you wouldn't have to coordinate among different transmitters. You know, everyone would get, you know, they'd calculate their own quasi-random transmit sequence based on serial number of the box
Right.
or whatever.
A more fundamental question is, how much do you need simultaneous range and range rate? You know, Doppler and time of flight. Do you need them? Because that is a fundamental issue when radar signal design, is getting both of those at the same time. You usually trade them off.
I mean, we always have the whisper signal sitting there for, you know, for probably
Yeah,
from
will they be co-located, sharing the same antennas?
That it might be nearby antennas.
Yeah, I don't know. It seems to me, for what you want to do, being able to do it with the same signal, the same antenna would probably tell you more.
Yeah.
So why?
Nathaniel can comment on this, but I assume that you would want to know range and range rate simultaneously for each signal if possible.
Definitely.
Why
Yeah.
would we not be able to extract Doppler,
Okay,
frequency information?
take the most common radar signal we see in HF. It's a chirp, and it doesn't take much to understand that Doppler or range and range rate are ambiguous, right?
Yeah. But that's a chirp signal. I mean, if we're not talking about a chirp signal,
No,
but just,
that's right. Well, I mean, my point though is the books I have, and I've been reading books on radar signal design, say this is a fundamental trade-off. You can do really well in one and poorly if you're willing to do poorly in the other. There are signals that do well in both, but they're often somewhat of a compromise. I mean, what you ideally want is a signal that a thumbtack correlation in 2 dimensions, where it gives you precise range and range rate at the same time. There's no such ideal signal. You can approach it with some good signals they describe, but nothing will be. It's a trade-off.
okay, just for my edification here, chirp and radar, I mean, that's typically used in, you're comparing your transmit signal with the reflected signal that you're receiving.
Right.
And you mix the two, transmit and receive signal together, and the difference basically gives you the range.
Right. Now, suppose there's also some Doppler on that signal and you don't know what it is. What's that going to do to your range estimate? You see?
Yeah. But again, that's why I think maybe chirp isn't the way to go with.
Well, I mean, I'm
range.
just saying that's one signal. That's one signal
Yeah.
does very well with range, but is ambiguous, right? When it comes to if both of them are there. I mean, one way to get around it is to have a Doppler signal along with it, a discrete Doppler signal along with it. You measure the Doppler first, and then you correct the chirp signal to remove that Doppler, so you only see the range rate part. I mean, that's one way of doing it.
Yeah. Boy,
You
guys,
just have to own it.
man, I wish I could stick around. Honestly, I got to run though. But one last thing. Chirp, again, it works great for a radar, ranging, on the reflected signal. But for a one-way transmission, what does chirp give you?
It's the same problem. I mean, you're just talking about a monostatic versus a bistatic radar. They're both radars. The only question is whether the receiver is at the same location as the transmitter or not.
Okay.
There are bistatic radars, right?
Yeah.
And that's what you guys are building, is a bistatic radar.
Okay. Well, I've got some thinking to do here. I will look up the CODAR, and you gonna be around next week? I mean, I'll if you want to risk this meeting devolving or evolving into time of flight stuff, I'd love to continue to participate.
Am I
with
going
you
to be
guys.
around next week? Yeah. No, nothing scheduled next week.
Oh, good. Okay, I'm looking at some messages here. Anyway, guys, thank you so much. This is really encouraging for me. And by the way, I'm really jazzed about our WWV transmit site. That is really fun news. Can't wait to get all the kinks out of that. And I'm going to leave now. You guys have fun without me, and I'll check back in later.
What I had just put in the chat is a link to a write-up that Steve Serwin did on the TDOA experiment that we did in October.
Okay, I just clicked on that, and it says you need access.
Oh, really?
Yeah.
I had essentially opened it on my Google Docs site and then copied a link. Let me see how I want to do this.
Yeah, I get the same thing.
Okay. Oh, I see. It says
well, I clicked on a button saying request access.
I should say anyone with a link. Okay, let's try this one.
Yeah.
Okay. Now we'll copy the link. Then try this link and see if that helps.
Looks good. Got it.
Okay.
All right. I'm gonna
there we go. I got it too.
Family dinner here. Got to go, but I will definitely read this and send off that email to everyone here that wanted it. And again, thanks again, everybody.
Yeah. The other thing that I was looking for in there was that he had a Jupyter notebook that they put together that they were using to create these waveforms. And I had access to that notebook at one time and made up a waveform with my call sign and stuff in it. And I don't seem to have a link to it anymore. I'm trying to find that link to that notebook.
I should be able to find that for you.
Okay. But I think that would be also interesting to share amongst folks here if they want to essentially, dabble in that and see, it'd be at least a good jumping off point to creating your own waveforms.
Yes.
How much trouble would it be to get special authorization from the FCC to run some unusual waveforms on the high frequency bands?
Well, if they're less than 2.8 kilohertz wide, in my opinion, you don't need an STA.
Okay.
Well, and as long as it's open source, right?
Right.
If it's documented, then it's supposed to be
I've
good.
already thought about how we could ID these signals. I mean, the classic way is a CW ID, but when you think about it, some hams on HF don't know Morse code anymore. So my idea there is to spit out your call sign as text on a waterfall.
Well,
to answer the first question, I don't think it's terribly difficult to get an STA. I was able to secure an STA for a vertical chirp ionosonde low power that we're doing for one experiment, and the STA went through fairly easily. Getting a more conventional experimental license was a bit more of a painful process, but we eventually did get it to go through. So I think if you write it up appropriately, it's probably doable.
What's waveforms were you sending and how much power, Nathaniel?
We're sending, it's just a linear chirp. And I think our license is up to 300 watts, but we're really not using more than 100 watts.
And how wide?
We can instantaneously, I'd have to look again. I know we can transmit from like 2 to 8 megahertz or 2 to 10 megahertz.
That would be the kind of thing you'd need an STA for.
Well, that's what I wanted to know. I mean, was how wide was your chirp at any one time?
Yeah.
I mean, obviously you're going to need one to go outside the ham bands, but
yeah. Our license says, well, the STA was 2 to 10 megahertz and 300 watts ZRP, and I don't. Our
what was the emission that?
The emission designator we used was 100 KFXN. So I guess
there you go, 100 kilohertz.
100 kilohertz.
100 kilohertz. Okay, well,
yeah,
you obviously need one for that.
Yeah, so I filed this with Bob McGuire, and we got it.
Okay. But those are, my understanding is most ionosondes are pretty short transmissions, right?
Yeah, we really haven't exercised using the entire STA so far. I mean, like we've really just done very short little things.
When I see what I believe to be ionosonde chirps, they're pretty short. I mean, they're rarely more than a second or two. So
yeah.
I mean, it can still annoy somebody, but it's not like you're on all the time, key down.
No, it's a lot easier to identify them if you have a waterfall display, that's for sure.
That's true, yeah.
So I did find the signal generator link. So here in the chat, let's see, there's a TDOA page, and then I think the link that you want is listed here. And there's the actual like GitHub page.
Yeah, okay, that's right. And I see on the hub page there's a TDOA SIGGEN dot JIPYNB.
Yes, that would be the one I think you want. And if
Yeah,
you
yeah.
see on the bottom where it says under the README, run link below to generate test signal. If you click that, it will run that TDOA siggen.ipynb file in a cloud server. So you don't even have to install it on your local machine to try it out.
Nice.
Right,
Yeah.
right. And that's what I had used actually to put together one with my call sign in it.
Yes, exactly.
Yeah. So, yeah, I thought if nothing else, this would be a good Kickstarter.
Yeah. And this was all done with yeah, Steve Serwin.
Yeah.
So this is really kind of his brainchild of doing this project.
Yep.
And we had some students we have some students working on this project, and they've made some really good progress with just using these chirps on a single side with conventional HF radios, HF ham radios, and they've presented the results at the CEDAR conference, and they're able to track some height changes in the ionosphere fairly nicely.
Huh. I heard from Bob that you guys succeeded at this.
Oh, so there has been a paper presented since the eclipse on this.
Yeah, well, a poster. I can link that in the chat too, I
Oh, the
think.
poster. Okay. Yeah, I would like to see that. Yeah.
Yeah, hang on a second. I can.
Since
And they've
participated in
they've
this, I kind of wanted to see what the results were like.
Yeah.
And I've been talking about this to some other hams, and they're all going, well, we'd like to see how it came out, so.
Yeah. Yeah, and in fact, that team, Steve Serwin and the students, they've been very active with continuing to work on this even since the CEDAR meeting. So the poster, I think, they're not the latest results. So, but if you're interested in, helping out or, following along with their progress, they meet on Zoom regularly. You can email Steve Serwin, and I'm sure he'll be more than happy to have you join in. So yeah, here's the let's see, share. Give me a second. It's generating a share link for you. Well, actually, that's well, that will work. Let me give you a different one because that's a really big file. Let me share this version instead. Share.
Oh, that one me directly to
a PowerPoint. Here, this.
Yeah.
Try this PDF instead. That's going to be a lot easier to deal with.
Oh, okay.
I got it. Oh, is this the one you showed in San Diego recently?
Yeah, that's right.
Okay.
So and they've continued to work on it since then. So I think they have better results now.
What was the publication date on this? I don't see that right off the bat.
June, early June 2024.
Oh, okay. So this is pretty recent. Okay.
Yeah.
I mean,
Yeah,
I always this.
Right. Because it wasn't the October one. The one I was working with was the one in April. Because
Right.
I essentially was at the Dayton KOA, which was in the path of totality, and set up a portable station there and was working with Steve and his friends in Texas on this.
Yeah. Email if you're interested in following along more closely, definitely email Steve and let him know that you'd be interested in helping with the analysis or following along, and he'll probably just let you know when the telecons are. And I know we're gonna work on doing another presentation, an updated presentation at the Fall American Geophysical Union meeting in Washington, D.C. in December. So
Okay.
yeah.
All right. Well, you gave me plenty of stuff to work with here.
Great. And for anyone who's interested, I've made a little progress here looking at the storm. Here's so this is the May 10th, 2024. We're calling it the Jennifer Gannon storm after a magnetometer scientist who unfortunately passed away at a young age right around that time. So I just pulled my Doppler data from the K9Q Whisper Demon grape system I was running. And so let's see, I think I have this should say WWV, and this should say port. I'll just put down Colorado here. Should say Fort Collins CO. So actually I should start with this. So here in this plot, this plot is coming from the World Data Center for Geomagnetism in Kyoto. And here we're showing three different magnetometer indices: the Aurora Electrojet, the asymmetric H index, and then the SIM H index. If you use these to tell you when the storms are occurring, we can look at this one at the bottom. You can see this little bump right here that happens right around 1710 UTC on May 10th. That's what we call the sudden storm commencement. So that's when the magnetometers on the Earth's surface first detected the geomagnetic storm. And then as this SIM H parameter goes more and more negative, that means that the storm is increasing. The ring current around the Earth is increasing. And so it gets to its lowest point at 2:15 UTC on May 11th right here. So that's the maximum of the storm. So this is called the growth phase right here. That's the maximum. And then this starts the recovery phase over here. So so I was looking at, okay, what happened right on May 10th, right around 17 UTC. And just looking at the data from my station, I can see right where you have this white dashed line here, that's 1710 UTC. That's the sudden storm commencement. So things are fairly normal before then, and then you can just see things going wild on 20, 15, 10 megahertz. We're not seeing too much down at 5 megahertz. And then over here on listening to CHU, actually I should flip these around so they're in the same order. I have them backwards, but you can see they're going 14, 7. There's crazy stuff going on here. Not much being seen on the lowest bands. So that was kind of interesting. Again, I've only put in my station so far, but I know other people have seen things. So there's quite a bit out there. Bill Engelke also sent me these spots. These are showing RBN PSK reporter and WhisperNet over the United States. I've been amazed at how difficult it has been to see geomagnetic storm signatures in these types of plots. I really thought that the signature would be clearer, but here's May 10th over here. And if I look around like 17 UTC, I can see maybe some funny stuff, but there's nothing that like jumps out at me right away. But one thing that is very dramatic is that if you go from when you go from May 10th to May 11th, there's over 10 million spots less observed on May 11th compared to May 10th. So that's a very dramatic drop off. And then I also want to point out that Gwen Griffiths wrote a very nice report. If you go to hamsci.org, right on the front article there, Gwen Griffiths wrote a very nice report to the FCC in response to their request for comments, and you can go there and you can read his report directly, where he's analyzing what's going on with Whisper, with the
Oh,
Whisper
this is great.
observations.
I wanted
Yeah.
to make sure the FCC saw the hams involved in this.
Yeah, so Rob will tell you that Gwyn is really the person who
I take, yeah, I'm he wanted to put my name on it because he thought it would be more noticed or credible at the FCC to have a US ham reporting, but it's really his work.
So I think I think this is probably one of the nicest reports I've seen so far that kind of lays everything out and puts words to it. So it was really nice that Gwyn put this in. And so I think I'm going to forward this on to the National Science Foundation as well.
Oh, absolutely. Yeah.
Yeah.
There's a lot of people out there don't realize hams can do serious science.
Yeah.
So what are you going to put in your report?
Me?
Yeah, to the FCC. Yeah, you seem to have quite a number of. At least you got a good presentation started there.
Oh, I do. Well, the issue, I mean, there are a couple issues. The FCC like only had a narrow window for the time of comments, and unfortunately, my problem right now is I'm just totally oversubscribed with a million things. And the same time that they wanted the comments in, we were busy in San Diego actually giving these presentations, and then my wife was giving birth, and then I'm also in the middle of trying to revise this other paper on large-scale traveling atmospheric disturbances, and I'm kind of putting all my effort into that right now. So there's just a million things going on, but we're doing what we can, and this is why I'm really glad that Gwyn was able to put this together and get this submitted, because it's really, really beautiful work.
Yeah.
Speaking of the solar storm, do you guys see there was another interesting consequence? All the Starlink satellites started autonomously maneuvering their orbits back up because of increased drag. And for several days, there was basically no conflict avoidance. Anybody hear that?
Wait, say that one more time, Phil.
When the solar storm hit, the ionosphere heated up rapidly.
Okay,
the density went up rapidly. Satellite decay rates in LEO went up rapidly.
Okay.
And all the primarily Starlink satellites started autonomously maneuvering to compensate for the drag. And during that time, this careful ballet they have of conflict avoidance among LEO satellites was basically operating in the blind.
Interesting.
Yeah, they actually said that quite a few satellites besides Starlink, I think, had to.
Well, Starlink is the vast majority of satellites in orbit right now. And the papers I've seen pointed out that this did not happen in 2003 in the last big solar storm, because satellites didn't have this kind of maneuvering. But of course, most of the satellites in orbit now are Starlink, and they all did this.
There's only about 6,000 of them up there, right?
Only about 6,000 of them now, right?
Yeah.
I'm using them
we
right
see
now.
them regularly go up from out here.
But there's still gaps in the coverage.
Yeah, apparently so. I mean, you wouldn't think. You look at the maps, the animations. Oh my God! I keep thinking of that scene in Wall-E, right?
Yeah. Now we were at a campground a few months ago where they were really big on the idea that they were using Starlink, for their Wi-Fi for the campground.
Yeah.
And what we noticed was very noticeable was on a fairly regular basis the signal would just go away for 20 seconds. because of the gaps in the constellation.
Well, you could probably figure it out. Just bring up Heavens Above or something and look at a map. You could probably predict what was going to happen. But it was interesting that for a couple of days there was basically no conflict avoidance. There were no collisions that I've heard of, but it could have. I wonder if anybody wants to take money when the first Starlink involved collision is going to happen.
Well, yeah, probability of when, not if.
Oh yeah, definitely when, not if.
Well,
I mean,
do you remember when
Yeah,
an
Iridium
Iridium
got
satellite got
remember?
hit?
Yeah. Yeah, with an old Russian
Right.
direct collision. I think it was the first time that it's been known to happen.
We
A
had
direct
balloons in
head-on
the air.
collision.
We had balloons in the air using Iridium to get our data back at the time that happened. I don't
Really?
think we lost anything from it, but it was in a different part of the constellation.
Yeah. Well, the one good thing that happened out of the storm is a lot of junk has been brought down to lower orbits. And the smaller pieces come down faster because their area to mass ratios are greater.
Is it Vanguard 2 that's going to be up there forever?
I think so.
Okay,
Maybe
can
I've
I
been into
use this opportunity to interject to Phil one more request for my ability
Okay,
to
here we go
adjust
again.
AGC.
Here we
AGC.
go again.
I've added Whisper Demon now can get the overload counts from K9Q, so we can document how if the input levels are overloading the analog to digital
Look,
converter.
I just gave you status outputs on the data channels. You seem very happy with that.
I am very happy with it. But I need to now. That's information now. I need to be able to use that information. In
Okay.
order to use it, I need to be able to change the gain of the without restarting your whole system.
Okay. Chemo's over now. I've had my 4 cycles. I hopefully should have less brain fog in a couple of days.
Okay. Well, anyway, I'm sorry to be persistent, but you were very helpful. You were very helpful
You're
with
nothing is
me
not
last year.
persistent, Rob. Of course, then things get done. So
Yeah, well, I try to finish projects that I start. So it's but in this case, I need your help.
Remember, I gave you a hard time in
No,
Cleveland, and I said, look, I mean, if it weren't for that, I wouldn't know what needs to be done. So
yeah. Well, it's I think I mean you were very helpful and you did point out that I really did need to look at the status information
yeah,
and then but you solved the problem of me trying to figure out where is the status information. Well, it's in there with
it's right
the
there.
data right
It's
there with
just
the
in
data.
a
Boy,
different UDP port in the same group.
Yeah, that's yeah.
Now, right now, that is fixed. I think I'm sending them twice a second. I think
Yeah.
that can be changed. Right now, it's compiled. It's hard coded, but that could be changed. So
That's plenty often. That's okay.
Okay.
These aren't exact measurements. I just take a sample once
Yeah.
every at the end of a whisper cycle, and I
The main-
determine
yeah.
how many overloads events occur. And interestingly, at WWV at W0DAS,
yeah,
even though well, no, that's not a good example. There's another one at KJ6MKA where the DBFS is -30. There's several hundred overload events per 2 minutes.
Well,
So
some
I
kind
guess
of non-Gaussian noise source. I mean,
it's yeah, there must be some non-Gaussian or so. Well, I haven't deployed this and looked at the logs from other sites. So, once I get this all 3.2 working, I'll get overload information from, all the Whisper Daemon sites. And that's key information about how to properly configure and assemble the whole and receive antenna system. So
yeah. I mean, you know why I put that status information there? My main use for it has been my FM voting receiver.
Yes. Okay.
It's
Well,
working really nicely.
Yeah. Well, you can decide whether to actually record or not record. Is that the idea?
Well, no, I have I'm a member of a large repeater network called the Papa system. I can receive about 12 repeaters here at home, all pretty well. But when I drive around, there's no one repeater I can just listen to. They all chop in and out because San Diego has so many canyons and hills. So I thought, well, why not just make a voting receiver? I've already got all the channels, just pick the one with the highest signal noise ratio. But I need to know what that signal noise ratio is. So I,
Yes. Oh, okay.
I put that in the status channel and I spit it out every 500 milliseconds so the monitor program can make a decision. Works reasonably well. I mean, it's got some, but works reasonably well. See, I'm trying to use this stuff for other than HF use. I make heavy use of this stuff on VHF and UHF too.
Well, we should hopefully we'll get to start to use VHF and UHF. I think that John Ackerman is working with Franco to test out 888 on VHF, and I think maybe he's starting with 6 meters.
Yeah, you quoted like a $300 price, I think, on the AirSpy. It's not that expensive. It's like half that, I think.
Well, that's what I've got from their
Yeah,
site.
I mean, it's still questionable, against the RS-888 coming down. It's still a questionable purchase, but it's not $300.
Well, the R2 is the one that I was looking at. The HF is inexpensive. It's 100 and something.
But it's one band. Yeah.
Yeah, it's one band at a time. The R2 is and it's also the HF is 30 megahertz and below. The R2 is the VHF UHF AirSpy, and that's the one that I don't know. They quoted what I got from my Google search popped up with almost $290. Let's see.
That's whoa. I mean, I know I have like 4 of them, and I know I didn't pay that much for each one of them.
Well, welcome to inflation.
I will. Well, yeah.
I think that. Yeah, I don't. Let's see.
I'll check.
Yeah.
I guess
don't plan to buy anymore because I plan to use the 888, but yeah.
I guess those $90 888s didn't pan out too well, though. Did
I apologize to anybody who is still listening here about having let everybody down that.
What happened?
It was a bogus vendor, so it was.
Did they not send you anything? Because I ordered 2.
No, they didn't. No, you should
I
register
just
with
want to know what that 60-pound thing that was delivered to New Jersey was.
They must have gone through and just with trolled for FedEx valid FedEx numbers, the tracking numbers, and just put one in to the response. To
charge.
Yeah, the idea was so that AliExpress would think that the vendor was doing the right thing by shipping it someplace.
Yes. Yeah.
Yeah. So I haven't looked yet. You haven't gotten anything?
Oh no, it's not going to come. You should go to your AliExpress and tell them I think you can tell them it's not arrived and the tracking information is bad. Go tell them before you.
Don't you need to wait until the at least the end of the promised delivery date?
I think you have to wait for 5 days or something, but yeah. But the thing was that people who contacted the seller were being offered 10 cents on the dollar.
I didn't get one of those.
They offered me 10%, then they offered me 90%. I've refused both, but I still haven't gotten my refund.
I haven't got my refund.
Well,
either,
I just refused to pay
I
it.
think other people have.
Yeah.
Yeah, but interesting that they were valid FedEx numbers, but they were for the wrong item to the wrong place.
Yeah, that's that he was doing that just so that he could essentially fake out that he was actually shipping anything. That's just one of those goofy things. I don't know. Last year I ended up essentially ordering something for my wife for Christmas off of a link that she had sent me on her wish list. And it went to a site called Ventalio.com where they sell kitchen gadgets. And I ordered this thing up, and then the next day they canceled the order. And I thought, okay, what the hell? About 3 or 4 months afterwards, suddenly my credit card company contacts me and he said, did you try to buy iPads at a couple of Best Buys in Southeast Michigan? And I said, no. And they said, well, that's good because we blocked the sale. Apparently somebody stole your credit card number. And so they went and cut it off. And what I found out over the next 2 or 3 weeks was that these people had not only stolen my credit card number, but they had also signed me up for 600 other websites. So I started getting this ton of email, congratulations for signing up for this account, blah, 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 over and over and over and over again. And the only thing that saved me was because I own the domain, so I use a different email address for every different online company I do business with. So they were all coming to ventalio@densby.com. So I could at least do something about that and move them off into a folder by themselves. But by the time that I got my credit card replaced, the company I get my credit card from also supports virtual card numbers. So I set about replacing all of the, stolen card numbers with virtual cards now. So if any of those ever get stolen again, it won't turn into the tremendous mess that I had this time. But I'd say it's worthwhile if you can find a credit card vendor that will support virtual card numbers.
Most of them do now.
Yeah. You can then protect your original card number at all these online sites.
But I haven't always been able to use them effectively. I buy everything on. I've never had any trouble with AliExpress personally, but I've gotten stern lectures from one of my banks. But what I do really is I do everything with PayPal for AliExpress. I don't especially like doing it that way, but at least I get them all in one place, and they have an extra outfit to go through, and I've never had any difficulty with that.
Yeah. Yeah,
Well,
well, there's a first
from
time
either
for
of them.
everything.
Yeah, I haven't heard either from AliExpress or PayPal, who I used about refunding me on this thing yet. So, by the way, I stand corrected. You're right, Phil. It's not that AirSpy R2 is $169.
Yeah,
right now from that. It seems more reasonable. So it's
yeah,
I mean, that was kind of my point. Is I thought this seems like a perfectly good receiver. So I didn't think that making the 888 work on VHF and UHF was a very high priority. It wasn't for me, since you support the AirSpy R2. But Franco did it, and if it works, then it's nice to have one device that you use for all, one SDR that you can use for everything. But I doubt that the 888 has a 3.5 dB noise figure between 42 and 100,000 megahertz, as does the R2. So
Yeah. So Elekitzer Parts has the RX-888 Mark II with a case, everything, for $169.99, which is probably about what I would think that you'd want to pay for that.
I'm gonna say 73, everyone also. Thank you.
okay. Take care.
Yeah.
Good night.
Yeah, Elekitzer